Alright guys, and you see it's separated into quadrants like any other normal circle. We have the
Sorry, Professor Nutt. Sorry I'm late. God, my alarm didn't wake up on time, and my car didn't start, and there was a school bus that exploded on the way here, and then Miss McNeil just started throwing hands at all the moms in the carpool lane, so I had to watch that, and I couldn't find my homework, so I think my dog ate it, but I hope I'm not too late.
Alright, Radrick, that's all very nice, but this is your third tardy this week, and that's unexcusable. That's a lot of attention, son. Darn. Sorry about that. Anyways, before we were rudely interrupted, this here is the unit circle class, divided into quadrants, standard circle, but it's also divided into radian parts, all based off of the values pi over 6, pi over 4, and pi over 3. And then it also has in each quadrant, it starts off at the 0 pi, 2 pi here at 0 degrees. At 90 degrees, it's pi over 2. At 180 degrees, it's just pi. And at 270 degrees, it's 3 pi over 2. So it's all split into those. And in between, each side has 4 different sections. The first starts with the 30 degree, 45 degrees, 60 degrees. That goes up to 90. Then it goes 120, 135, 150, goes back to 180, 210, 225, 240, back to 3 pi over 2, then 300, 315, 330, all the way up back to 360. 360 degrees, your standard triangle, and the values of each of these, you see, each line has a coordinate for itself. The x value here, that's the cosine value. The y value is the sine value. So you see there's a cosine sign for every single value. Let's say, for example, for pi over 4 or 45 degrees, the cosine value would be root 2 over 2. Here you can see that here. Or the sine value for, let's say, 210 degrees would be -1, because on the third quadrant, both sides negative, it drops down. And then there's also tangent, which is the y value over the x value. And that's, let's say, tangent for, say, 120 degrees, that would be 3 pi over 2 over -1/2. That would end up being -3 pi. So that's just an example of that.
Excuse me, Professor Nutt. Can you explain the unit circle again? My dad taught the unit circle back when he was in school, and I also learned to ride horses there. Can you teach me the three trig functions again?
Oh, that was very relevant. Thank you, anti-slime. Yeah, sure. There's 3 other trig functions. Almost forgot. Actually, thank you for that. There's also cosecant, secant, and cotangent. And those are simply the inverse of each of those. So one thing you can see here, let's say the cosecant of 60 degrees would be, that would be the sine value inverse. So that would be 3 pi over 2. That would be 2 over 3 pi over root 3, that would turn into root 3. It's just root 3 by itself. And then you'd have secant, that's simply this inverse of cosine. You get that by the same method. And then cotangent, you get that by how that's done. And so, yeah. And then, are you kidding me? Hey, Tiger, wake up.
Professor Nutt, stop throwing erasers at me. Can you teach me about reference angles again?
That's actually a good question. Okay, Tiger, oh, great. Alright, so you see the reference angle itself is just the amount of distance any given point is from the x-axis. So say for 30 degrees, the reference angle would just be 30 degrees, because 30 degrees from 0 right here. But then for, let's say, 135 degrees, the reference angle would be 45 degrees, because it goes up 2 sections from this side of the x-axis. Then let's say for 240 degrees, that would also be 60 degrees, because it's 60 sections away from the x-axis from here. You wouldn't be doing it from y-axis, it's always from the x-axis, the nearest one. And then let's say in the 4th quadrant, you ask about 315 degrees, what's the reference angle there? The reference angle there would be 45 degrees, because it's 2 sections away from this side of the x-axis.
Oh, Professor Nutt.
Yes, Roger.
I don't think I was here. I think I was late. But co-terminals, have we already covered that?
Actually, Roderick, another good question. No, we did not go over that. You're good. But, yeah, work on that attendance anyways. But, yeah, so coterminal angles, it's actually fairly simple. If you're given an angle, a coterminal angle would be the same spot in, let's say, if they added 360 degrees. So let's say there was from 6 degrees, a coterminal angle there would be 420 degrees, and then let's say from 30 degrees that would be 390 degrees. Let's say in quadrant 2, if you went from 50 degrees, you went from 135 degrees, that would be 495 degrees, the coterminal angle, the angle there. And then one from quadrant 3, if you went from 210, add a 360, that would be 570 degrees. Or you can also subtract the value itself. So let's say the negative coterminal angle from 360 here, you subtract 360, that would be negative 300 degrees. So that's coterminal angles, guys. And yeah, that's